Hello, this is Steve Shrimpton from Wifitrax, and today I'm going to introduce you to one of our new switch machine products, WS-48. Now it's a 4-channel Wi-Fi DCC servo motor controller, so it can be used to drive any small servo motor, and such as using a servo motor to control turnouts. But you can also use servo motors for other things, semaphore signals, level crossing gates, whatever you can think of. So the WFS-48, as you see right in front of you here, has power input on the right, and it's got a full wave rectifier on it, so it doesn't matter which way round you connect the power. On the left here, we've got a DCC input, and at the bottom we've got a set of pins where you can connect 4 servo motors. Other connections here, we've got an optional external servo power. We've got an internally generated 5 volts stabilized power. And there's a couple of links here where you can select, if you put the link on int, then all the power going to the servo motors out of the connection pins here comes from the internal 5 volt generated supply. And if you put it on X, then you connect your own servo power here, in which case you could use a somewhat higher voltage, or if you've got bigger servo motors that require more power, you could use the external option. So now I'm going to go ahead and connect up the power here. I'm using 15 volts DC coming from just an ordinary power adapter that you get at your electronics hobby store. I buy them from DigiKey. They're a Meanwell type. I'll give that information later. It doesn't matter which way round you connect it, but you could also use DCC here. The board runs quite happily using DCC as the power, as well as DCC used as an input. Okay, so I've finished connecting the power there. I haven't turned it on yet. So now I'm going to connect up a one test servo motor. Again, I bought a set of these from DigiKey. I'll give you information about those later. That's the cheapest servo motor I could find. Works very well to control switches. Now, looking now at the outputs, we'll use channel 1, and channel 1 has 3 pins: ground, 5 volts, and the control. So the ground and 5 volts supply 5 volt power to the servo motor, and then the control pin has a pulse on it, and the width of that pulse determines where the servo motor will move to. So I'm going to go ahead and connect this up now. So we need to make sure we've got it the right way round. The yellow wire is the control, so we'll connect that on the right. Push it down firmly. So now we're about ready to give it a test. Okay, so what I'm going to do now, having connected the WFS-48 to power and to a one test servo motor on its channel 1, so I'm going to use my iPad to give it its first test. So let's first of all go ahead and turn on the power, and you can see that the red LED lights, which shows that you've got power. None of the other 3 LEDs are on. The blue LED will come on if you've got DCC going into the DCC input. The green LED will flash if there's network traffic, and come on continuously if you're connected to a router, a local area network. So going to the iPad, I've got my iPad propped up there. So the first thing I want to do is to go to the settings and go to Wi-Fi, and you can see that the iPad is connected to a local network Wifitrax Demo 4, which is one of my test networks. What I want to do, what I have to do before I can test the WFS-48 is to connect to the Wi-Fi access point, or the network, that's owned by the module itself. So it advertises that on, to the iPad, that there's a Wi-Fi access point there called Wifitrax WFS-48 _1 _236 7. The long 8-digit number is the serial number. The 1 is the channel number of the Wi-Fi channel number, channel 1. The 7 on the end is actually the subnet number. And what I mean by that is it's the third digit of the IP address that the module itself will have. Okay? Right, so let's go ahead and tap on that. And we should now connect to that network, and it's there we go, connected. Okay, it's an unsecured network, you don't need a password. So we're now ready to start talking to the module. So let's now go back to the home screen and open Safari. And Safari, I'm gonna type in the IP address that the module has, which is 192.168.7.1, and then hit go. And what we now see is we now go to the web pages that are generated within the module. The module has its own web server in there. So instead of going out to a web server like, Google or something, you're going to a web server which is actually on this little module. And so instead of typing in google.com or something, we're typing in that IP address there. And the module then comes back with its web page. And so you can see WFS-48 web page, the IP address which the module actually has on its own network, and the main menu options. So at the moment there's only two things on the module's network: the module itself and this iPad. Okay, so now to do our test, we're going to go to the Switch Machine channels option, and we see a list of the channels, and they're actually numbered with an index 0 through 3, whereas on the module they're actually numbered 1 through 4. So sorry, you'll just have to get used to that. They've got default names. They've got default DCC addresses. We'll need the DCC addresses when we come to actually connect DCC to the module. And the default power-up state is with all of the turnouts in the closed position. Right? So now let's go ahead. You can just about see the test servo motor itself. So I'm going to go ahead and tap on there, and sure enough, it swings around nicely. There we go. So that's our first test completed. Now let's continue to explore how we can set up this one servo motor on channel 1, or channel 0 as it is on the screen. Okay, you notice that when I hit closed or thrown, the servo motor swings through its entire travel. Now often we're not going to want that. We're only going to want it to go a small distance. I mean, you could sort of solve that by maybe some leverage arrangement, cutting the arm, the plastic arm, or something like that. But I've got it in this product. We've got a good way to do it. So you can set up details of the servo motor channel by tapping there. Now, what we see here, first of all, we see a name. So let's give it a nice name, shall we? We'll just call it something like 0.1. Okay, and we'll leave the DCC address at 100. We'll ignore these other things for the moment. But what we will do is we'll set up a more limited range. So we've got this slider here, which we can tap, and if you can see it, as we tap it in different positions, the servo motor moves to different positions of its travel. So let's suppose, just set it to, say, there, and we'll make that the closed, or even make just a very small travel. We'll make that the closed position, so we hit save closed, and then we move it again to a different position, and we'll hit save thrown position, and we'll also hit save, which we haven't okay, we haven't saved the title, so the name. So let's go back and do that name again. Okay, 0.1. Okay, so now if we hit thrown and close, you'll see it just moves through. Let me show you more closely. It just moves through a much more limited range of travel. So when we're using this to control points or turnouts, we're going to want to sort of adjust this so that the tie bar moves far enough to just give a little bit of pressure of the point blades against the rail stocks, I think they're called, on in the thrown and in the closed position. So you can see it's very easy to set up the range of travel here. So now we look at actually making a switch machine for use with the WFD-48. And here are the parts. I made them myself. I 3D printed the white plastic parts, and as I've said before, the servo motor itself comes from DigiKey. It comes with a selection of plastic arms, cranks or arms, whatever, and 2 mounting screws. There are 3 more screws there needed to fix it to a baseboard and 1 to fix the cover on, and then the cover and the frame itself was 3D printed. Then you need a little bit of spring steel wire shaped to fit through the hole there and fit into the crank of the servo motor. So here's the switch machine partially assembled. Okay, so just looking at the other side. That's how the crank works. The crank's been cut down to reduce the amount of throw, and of course we can adjust the start and end position as I explained before. There's the spring steel going through a hole in the baseboard to fit through the hole in the tie bar of the switch. Now here it is fully assembled with the cover on. So cover's nice under the baseboard because it stops you from damaging it if you're crawling around or keeping dust and fluff and stuff out of it. Now here I've made a test setup with 2 old points connected with the switch machines that I just described underneath. So there they are, they haven't got the covers on. So there they are, all in position with the spring steel wire coming through holes in the tie bars, just as though you were using a tortoise switch machine, something like that, and connected to the channel 1 and channel 2 outputs of the WFD-48. So what I'm going to do now is adjust the positions, the thrown and closed positions for the two servo channels, so that the points close and throw correctly. Okay, they're both set sort of in the middle at the moment. And if we look at the way I've got it set up here, if we look at point 2, then you can see the closed and thrown positions, pulse widths, which translates to positions, is the same. So what I'm going to do now is look at point 2 and just set it up so there's a good So there's a good thrown position. So we save the thrown position and then move it to a closed position. That's about right. And save closed position. Okay, and then go back out of there. And now we should be able to operate the point. There we go. So we've got slow motion built in. Now actually, point 1, the other one, is actually installed with the switch machine reversed, because the point's effective because the point's pointing the other way. So actually, when we do point 1, we'll have to do everything in reverse. So we'll select the thrown position and call it the closed position, and then we'll select the closed position and call it the thrown position, and save. And now what happens now is that closed is really thrown and thrown is really closed. So we can go back into there and check that reversed and save, and now it's correct. Thrown, closed. So that's another feature that you can use. Just double check all that. Thrown, closed, closed. So everything's good on those two channels. So now we've explored how to set up the channels on the WFS-48 Servo Motor Controller, and how to operate it from its own web page, channels, Switch Machine channels web page. Okay, now that's all very well, but on a major layout, you're going to want lots of these controllers, and maybe some of the other controllers as well, Switch Machine controllers as well. Maybe you'll have some tortoise switch machines, maybe even some twin coil switch machines. So the next couple of videos, I'm going to go through setting up the stall motor switch machine controllers and the end switch motor switch machine controllers, and then we'll integrate it all together and see how to use a WFD60 to control it from a schematic diagram, or from a list of turnouts, or indeed from something like a TCS UWT, or your phone using engine driver or Y throttle. Thank you.